Welcome everybody. My name is Corrado Maggi. I am from the company Clean Air. Clean Air is a manufacturer of filter cage for filter bags for dust collectors. We appointed Politecnico of Milano last year to make a study to try to carry our, let's say, our batteries in the dust collectors on the side of filter bags and filter bag cage. So basically, I'm here also on behalf of Politecnico of Milano, because in this study we have worked close with Politecnico of Milano, and particularly two departments of Politecnico of Milano, the Environmental and Civil Department with Professor Messa, who makes a computational fluid dynamics study, a simulation, and then later on with the Mechanical Department of Politecnico of Milano to validate what we have done in terms of computational simulation, computational fluid dynamics. The domain of our study has been already presented, because this is the second part of the study that we did last year and presented to this conference last year, and was relating an attempt to better the cleaning operations in dust collectors, so filter bags. The academic base, that was the main first study of Politecnico of Milano, was relating a Chinese study of the Shanghai University 2019, made by these two academic professors, Yu and Chen. Of course, I believe in this room everybody knows about the functioning of a dust collector. So a jet pulse, there is some air injected by a nozzle inside the filter bag, and the filter bag is crawling, would cause the dust to be in the hopper. And so basically I will not spend too much time over this. Computational fluid dynamics, of course, provides a series of advantages in terms of tests. So distributed information, many parameters could be evaluated, but also we can imagine different size of plans and simulations in a way that this will not be so expensive, so not impacting too much on the budget of the companies. And nowadays there are also software which are more friendly use on respect to the past. Of course, we need the help of Politecnico as Clean Air, because these software are very expensive as well. There are some defects, of course. There are a lot of computational burden, so it's a team that should be cleared, and then also source of uncertainty, which could cause probably the model to be maybe not working properly. So we have, as explained last year, we have tried to make a study by comparison, so not taking as absolute value of our findings, but just considering them in comparison with other solutions and measuring in terms of performances. So basically, there were two phases. Phase last year we presented until the experimental validation of the Liu Shen, with explain. And this year we went into this past year, we went into the application and into a product solution that we test by a characterization on field, and with a final shape that we found to be more performant in bettering the dust release process. Basically, the computational fluid dynamics we imagine was able to analyze numerical convergency, impact of modeling factors, until the validation of the study of academic study of the Chinese. Why? Because the Chinese made a real small system, but real, and we put their data inside our computational fluid dynamics, and we found they were consistent. So then we went to imagine how to better what they did, and we found, let's say, our solution. That is what we are going to show today. So basically, according to Liu Shen, there were two parameters involved, mainly two parameters involved in bettering performances of the dust cake release, where the peak pressure and the peak pressure arrival time. So basically, the speed with which the length, the injected air could reach over the time the length of the filter bag. The first points that was already settled last year was to define the correct time step size and the computational mesh, because this is considering the fact that many times, many hours per day, working PC hours are needed to make simulations, and we have a limited time to do this. And so we find out by sensitivity analysis that we can use a time that was 10 minus 5 seconds and 50 to simulate a filter bag, a single filter bag of 10 meters length and 50,000 cells in the mesh. That has been found to be good and with no sensible mistakes in the repetitiveness of the test that we done, that the Polytechnical done. Of course, other models must be considered, like a thermodynamic model, the fabric model, fluid dynamic model. That's what we said is very complicated, could be very complicated. That's why Clean Air also choose to work with a university, because we cannot manage by our own these data, and the equations that are behind are very complicated, as everyone knows. Also, sensitivity analysis has been done on the model, the mathematical model for this. Maybe you can address the Professor Mesa for any question, because I'm not in the possibility to answer properly if you have this kind of curiosity. But we found, basically, we tried to find the best compromise, the best trade-off to validate this before considering the application to Liu Shen specific case history. That has been done, of course, and this special image that you can see on the right was what they have tested, and of course we found also some differences in the solution of the cage without any venturi. That is 25% difference in the performance, speaking about, for example, the peak pressure. So basically, we validate our simulation model, and we passed to the second phase. The second phase was, okay, if the layout number 3 is number 2 with some differences, the layout of this Liu and Chen, we would like to see what is happening without the venturi or with the traditional venturi. That is the layout venturi number 1, the traditional mounted venturi on a cage, no? The one that we are selling regularly. And we found some better performances in terms of peak pressure and the peak pressure arrival time, which is the second graph. You can see the black is the top, layout venturi 2 was the top performer. And also in terms of mass over air entering into the bag. So there was a third parameter considered, that was the airflow and mass. Then we started 1 year simulation, that's from last year to, let's say, conference to this year, where we have modeled all dimensions of this venturi, and one by one we change them, bigger, smaller, bigger, smaller, bigger, smaller. So try to understand what was impacting, of course, these two variables that we said before. And of course, we did this by simulation, because we have validated with the same data that we had before. Our idea was to come to a new shape, a new venturi that could perform better than the traditional one we are mounting from several years in our cages. We are a manufacturer of cages, as I said. And that was on the left side was a little bit our idea, but still we are missing information to know if we can work. So in this case, another test was performed, was the physical computational fluid dynamics representation of our idea against the traditional most used and common Venturi tube from one of our filter house dust collector manufacturer, and used by one of our dust collector manufacturer. What we found is that we were able to better, in a sensible manner, and along all the position of the bag, so along the meters, the length of the bag, the peak pressure, and decrease the peak pressure arrival time at the end of the bag. Of course, this comes to be also in some times and a value that even is for some meters, some position even comes to a double or even impact more than 50%. So it was a big difference that we would like to evaluate better. Also on side of air inflow and mass that is passing through, we have a sensible increase of treatment of mass entered through the Venturi entrance, and so also for the mass flow ratio. In order to be sure that what we were finding, our findings, we went on field, thanks to the help of Velvo manufacturer and tech manufacturer, which is out in Italy. We went to their facilities and we asked to make a test together with them. Of course, the test was run by Politecnico Milano. And we make a test at 3, 4, 5 bars for compressor by placing several sensors along the bags in specific positions, as you can see here, 5 sensors for 9-meter bags. And we analyzed with the sensor this wave. What you can see in the blue on the left is the beta wave inside both positive and negative pressure of what we call eco-turbo, so our solution with respect to the traditional Venturi. We also vary some the position of the nozzle in order to exploit the wider surface of our Venturi solution. What we found was confirming that sensor at P2 at 3 meters, at P3 it's 5 meters, so basically a good covering of the solutions in the market, of course, depending on the applications. We're substantially increasing the peak performances of peak pressure performances in a device that has been traditionally considered, it's an old device, Venturi was an Italian scientist of 1000. But there was still room in some way to better what was considered to be, let's say, stable. Of course, there could be and there will be possibility to test what we've done in other and for future. So there are other lines for continuing this job, which is not completed, but which has generated a specific product that we have already placed in the market, which is designed in 3 different dimensions to cover basically all the filter bags that are used in dust collector, in industrial dust collectors, with the aim to have let's say a tube, a Venturi tube that was able to be reused, so also for refitting purposes. As you see, the 3 dimensions that we have provided, and basically by resuming, we can say that the advantages of this why at the end having this Venturi more performant Venturi, because by increasing peak pressure, of course, we can decrease the frequency of the cleaning in the filter bag. So just looking at the cleaning parts, the cleaning job, we can decrease the average delta pressure presented in the plant, is the red curve against the green one. At the same time, Venturi has been studied not to limit the entrance of the circulate hole, which is, let's say, a defect normally attributed to a Venturi tube, that during the working conditions, the advantages of a better cleaning might be, let's say, ruined by the fact that the Venturi is needs more energy from the fan in order to be operated because it's restricting the air inlet. Our Venturi instead is not restricted at all because it exploits this top flange effect to enter a second flow of air in cleaning, but at the same time permitting the air to be, the out air to be treated outside. So is a kind of trade-off in between increasing the fan energy problem due to the Venturi presence, and on the other side decreasing the frequency, so the energy for air compressed and compressed air consumptions at the same time. The team that work at this, of course, I'm just an air representative, a messenger, I would say. The idea, of course, was the idea of Clean Air to try to give its contribution to the bettering of the industry. We are just a small company. But we work with a very good team in Politecnico Milano, as I said before, and the professor did the most difficult part of the job. Thank you.
Thank you very much, Corrado, for this interesting presentation, which is also open to discussion. Yes.
In your CFD setup, you said that we evaluated 2 designs. So in that, did you use compressed air at the injection, or
yes.
How it was done?
Yeah, it was modeled by considering the tank and then the injection from the tank closed. There is, of course, this belongs to the first study that we did. So maybe you can, can give you the paper of the first study how we consider and model the injection in the nozzle system to inject the air. Once, let's say that once we inject the air, we close the tank, and then we have analyzed the flux over the time, so we fixed a specific time in milliseconds, where we have analyzed the curve, because this curve, of course, is changing, the pressure curve is changing depending on the injection time, so going into more deep or stable.
Yeah, that's true. If you have a solenoid, probably will have pulses of compressed air being sent
Yeah.
to
Yes.
the ventilator.
Yeah, so we modelize one single pulse, of course. Yes.
The question is, did you also measure the mass flow rate or volume flow rate? Because I believe these things will work hand in hand.
Yes, there were several variables to consider, also speed and other speed. We have measure all, but we focused on the peak pressure and peak pressure arrival time to determine, because that was the base of the academic job, and widely recognized. What we did before, Politecnico did before, was to analyze that these conditions were consistent in all the computational fluid dynamic study that were made before. So maybe if you need more information, more specific question on computational fluid dynamic, I will put you through the Professor Mesa, because he is the one who knows better than me this kind of parameters. Okay.
And are you also planning to do any particle dislodgement studies, which will directly tell you efficacy of this whole thing?
What do you mean? Sorry.
Like you have particles on the filter media.
Cleaning efficiency.
Yeah, of course. This is a little bit what is missing, because when we test, we simulate the presence of dust on the testing outcome. But this is true. The effect of the dust is still something. Is the part that we have to, let's say, to consider, because of course there has been a study about permeability problems. So our permeability, of course, is impacted by the dust layer, because this academic paper has been carried also to by continuing, but is another paper. There has been a second study made by Politecnico Milano and carried to hydraulics in Parma this year in September 2024, analyzing this aspect by variating permeability to see if this was impacting how it changed the model due to this, but still on computational fluid dynamics, not on field.
There is still room for another question. Yes, please.
Okay, will you please elaborate on the next project that I saw there? It's about filter back elasticity modeling, something also
because of course there's lots of discussion about the fact, the pitch, you know. I mean, the speed of a point of a filter bag in detaching from the cage. The speed is also related to the distance and the acceleration of this point. Because this is going to impact the dust cake release. So we are, besides of course, the big pressure, the wave power of the pressure, is also how much distance we can. And so this is another point, not easy. A lot of people would like to measure this. We have made these discussions at the early stage now. It's an early stage with Polytechnical, because we know there is this kind of impact, and we think it's worth considering how to analyze it. Yes.
Okay. Because our experience with some of the filters like polyacrylic,
Yeah.
we realized that as the operational hours increase,
Yes.
the bag sharing can stick onto the cages.
Yes. That's
So
true.
that makes also the cleaning.
Yeah, there are several factors. We try to isolate some, and just use a model by comparison as easy as we did before. I mean, comparison model. We know it's better. How much is better? Not easy to say, because depending on so many conditions, like also these conditions. But in the same conditions, adding our eco tool with better performances in terms of dust release. Okay.
Thank you very much. I think with this contribution, we would like to end today's session. I would like to thank all the speakers for their interesting presentations, and I wish you a pleasant evening. I think there is a reception down there
Starts now at 6 p.m. at
6
Konrad Adenauer. So.
This is good for the town.